Hello and welcome to the WGG how-to video for Hover Above It All. In this activity, learners will create a hovercraft which moves over land and water using simple materials such as a compact disc or CD, water bottle, and a balloon. In this activity, learners will take on the STEM career role of a mechanical engineer. Mechanical engineering is one of the broadest engineering disciplines, as mechanical engineers design, develop, build, and test mechanical and thermal devices, including tools, engines, and machines. The STEM big idea for this activity is friction. Friction is a force that is produced when objects rub against each other, such as skis against snow or feet against grass. The big idea here is less friction, movement becomes easier, faster, or smoother. More friction, movement is harder, slower, or rougher. Now let's apply this idea of friction to hovercrafts. For a hovercraft to float above a surface, such as land or water, the engine must produce enough air pressure to lift up the hovercraft. In the air, the hovercraft moves easier, smoother, and faster. This is because air resistance, a type of friction, is less than friction on a surface such as water or land. In this activity, learners will design and create a model or an example of a hovercraft using a balloon, a water top, and a CD. Like the hovercraft, the balloon will release air, creating enough air pressure to lift the CD, top, and balloon off the surface so that it hovers with less friction and is able to move easier, faster, and smoother. The materials needed for this activity include a box fan, balloons, scissors, a hot glue gun, water bottle, CD, ruler, and a timer. Before the kids walk in, you want to make sure that you have familiarized yourself with the design challenge. You have all your materials that you need ready to go. You've read the facilitator guide as it contains many important details for this activity, and you've set the activity up so that when the learners come in, they can begin to have fun. There are several ways to get the kids excited about this fun hands-on activity. Show them images of hovercrafts over land and water. Ask them to share what they think is exciting about these vehicles, as well as their ideas and explanations for how they think these vehicles work. In addition, you can ask learners questions about their everyday experiences, such as skateboarding, riding in a car, going down a water slide, or any interaction with a surface that is smooth or rough. In addition, you can create a shared experience with the learners. For example, you can have learners rub their hands across the table or slide their feet across the floor with or without carpet. However you engage learners to think about their experiences with friction or their ideas about hovercrafts, be sure to always ask why. This gives learners the opportunities to explain their ideas and learn from each other. Now, let's check out some highlights for this activity. As always, when learners log into the WGG environment, they will view a set of steps for this activity. The first step introduces the activity with a little background information and previews the design challenge for learners. Later in the activity, learners will become familiar with the design criteria for the design challenge. In this activity, learners will evaluate their hovercraft based on levitation. How long will their hovercraft float above the surface? Learners will also consider the distance the hovercraft travels across the surface. For additional fun, learners can earn bonus points for the hovercraft that has the longest levitation or travels the longest distance. Now let's turn to the construction of the hovercraft. Starting with the cheap water bottle, you want to use your scissors to puncture and then cut off the top portion. After you finish cutting the neck of the bottle, place tape around the edges so that they're smooth and they do not pop the balloon. Using your scissors, you're going to puncture one or more holes into the bottle cap. Make sure the holes fit within the circular area, the size of the hole in the CD. The cap should be attached to the shiny side of the CD. That's the side with the ridge around the center hole, not the side where there are words written. And be careful to center the cap when attaching it to the CD. After you attach the balloon to the top of the water bottle, blow it up by breathing into the balloon. To complete your model or example of a hovercraft, screw the top of the water bottle with the balloon into the cap that is glued to the CD. Now it's time to test this model of a hovercraft. With the inflated balloon, place this model of the hovercraft in front of a fan. As the air is released from the balloon, this model will hover above the floor. The fan will then blow the hovercraft as far as it can go. When the hovercraft comes to a stop, you will want to use a ruler to measure the distance traveled. After all learners have had the opportunity to design and build this model of a hovercraft, be sure to bring them back to the WGG environment and have them reflect and evaluate their design. Remember, the design criteria focuses on levitation, that is, how long did the hovercraft stay lifted above the surface, and distance, that is, how far did the hovercraft travel when blown by the fan. Learners will earn bonus points if their hovercraft levitated the longest or traveled the farthest distance. Finally, we have a few facilitator tips where the gotchas can get you. Remember, cheap water bottles work the best. The plastic is thinner, which makes it easier to cut. To cut the water bottle, you want to puncture first, then cut second. Also, you want to remember to have the learners place tape around the cut area of the bottle to prevent the balloon from popping. And since this activity is focused on reducing the amount of friction, just remember smooth surface to smooth surface. That is, the smooth surface of the CD should be against the smooth surface in which you test the hovercraft. And while we encourage teamwork, for example, it takes two to attach the balloon to the CD, we also want to be sure that we're not sharing the balloon and therefore sharing germs. In the end, we hope these tips help you to facilitate a fun, hands-on STEM learning activity where learners have the opportunity to design and test a model of a hovercraft that helps them understand the concept of friction, as well as maybe even consider a career in mechanical engineering. Have fun!